in the last lecture, we had seen the supervised learning. Now I want to give you a very brief on unsupervised learning. So there are two types of unsupervised learning that we are going to see in this course. One is clustering and one is dimensionality reduction. Okay, so let's start unsupervised learning. So what is unsupervised learning? Okay, so unsupervised learning is, so what was supervised learning? Supervised learning was training with labeled data, right? In unsupervised learning, you will basically have unlabeled data. Fine. Your data will be unlabeled. So it's like self-study, right? So if you're going to self-study, you will learn the concepts. And suppose you have, for example, suppose your mock test doesn't have marks, right? Sorry, mock test has marks, but it doesn't give you the right answer back, right? It just gives you a score like, okay, you are 70% correct, you're 80% correct. On basis of this, if you analyze and you're able to recognize like, okay, what question I'm able to answer or what question is right or wrong, then it's sort of unlabeled data, right? So you're basically learning without labeled data. And so the first very obvious question is, why do you even want to learn without labeled data, right? So to tell you honestly, I think greater than 90% of the data that we have right now, right, is unlabeled. So the company that I was working for, they had some 9 million ECGs ka data. Okay, so 9 million ECGs. And every time we wanted to train a disease model, we used to first go and label the data. And that used to be like a very huge effort. So labeling data is a very huge, expensive effort. Labeling data is huge and expensive effort. Like it used to take us a year also to label the data. And still we used to struggle getting the label data right. It's expensive. It's huge and expensive, right? So the data that we have mostly is unlabeled data, right? So if you don't have the labeled data, what will you do? You will basically try to use learning techniques like unsupervised learning, which gives you insight in data. And sometimes unsupervised learning is used to tag data or used to label data, right? So there are multiple paradigms, multiple ways unsupervised learning is used. I have mainly worked on this domain in industry that you used to have huge amount of unlabeled data. And then we used to do clustering or dimensionality reduction and see to get some insights like what is happening. Are we learning something? Are we able to label data based on some insights that we got after unsupervised learning? Okay, so there's a question. Labeling the data means predicting output or existing output. Labeling the data means existing output. Like, for example, suppose I give you this ECG. Okay, this is ECG1, right? You don't have any label associated with it. You don't know what diseases are there for the patient who has this ECG. So you don't have any data, like no data about this, right? So this is just a single ECG that is sitting. There is no information associated with this, no label. So sometimes what you'll do is you will use unsupervised learning to label this data. You will see, we'll come to that, but you will use some techniques so that probably you will figure out, okay, these ECGs belong to this particular disease. So you'll label them with this disease, right? Or another set, you will say, okay, these ECGs does not have this disease. So you will label them accordingly, right? So basically, there is no labeling available. It's just the data. For example, if I start scanning your medical documents right now without any diagnosis, I will, for example, you guys will take ECGs whenever you're going to IIC, right? If I just collect all the ECGs of IIC students and I don't have the diagnosis associated with it, that is just ECG. there is no information associated with it, like what is the patient age, what is the gender of that patient, or what diseases does this patient have. Nobody, like, no information is there. Only on the basis of ECGs, you want to do something. You will do something, try to gain insights from it. You don't know whether you'll be able to gain insights or not. But there are techniques that we use to see if we can gain some insights from the data, just the data, no labeling. Okay, fine. So I'll give you some examples. Okay. So learning without data, right? So we are very good at learning without labels, sorry. So suppose that your friend gives you three types of coins. Okay. Three types of coins, and they are not, they are of same size. They look similar, but they have different weights. Different weights, but same size. Same size. Here I have shown you different colors, but same color. Say gold coins. Right? Say these are gold coins, right? And they look exactly the same somehow, right? Now your friend tells you that the heaviest coin has higher value. Okay. So can you determine the order of value for these coins, three types of coins? So this is type 1. This is type 2. And this is type 3. You don't know anything about this, right? But just that, may probably you know their weights, right? Just the weights. But can you, based on these weights, can you find the coins which are most valuable and then less valuable and then less valuable? Okay, others, think about it. So the heaviest coin, use the hint. The heaviest coin has higher value and you know the weights. This is the hint. I've written it. Yeah, you know, basically, you know, you can measure the coins, okay? So you have a weighing scale, right? You can. Okay. So what I'll do is I'll get a weighing scale, that one that you used to measure, that you have in kitchen. I don't know if you guys have it, right? And I'll put each coin on that weighing scale. Okay. So my coins will lie like this, right? So the coins which are of the lowest weight will come together here, right? So there are three different coins. So there'll be three different groups that will be formed, right? So the coins with the lowest weight will be here. I'm saying, for example, they're 1 gram. Can you see that they're exactly not 1 gram? Like they're slightly here and there because of usage, right? When you do usage of coins, they wear and tear, right? So because of wear and tear, their weights might differ. And sometimes, they get dirty. So they like a little bit of weight might get added to the coins, right? So because of wear tear, they can gain or lose weights. So whenever I will take the weights, I will get all the weights here, right? The lowest weights, right? Then whichever are like higher weights here, I will be able to collect them here. And whichever have the highest weight will be collected here, right? Now, can you tell me which one, tell me the color of the coin which has the most weight or most value? Tell me the color of the coin which has the most value. Okay. So I said heaviest coin has higher value, right? So which color? Heaviest. Heaviest coin has higher value. What is the heaviest coin here? Heaviest coin. Tell me the heaviest coin. Oh God, you guys don't know 10 grams is greater than 5 grams is greater than 1 gram. These are the coin colors, okay? I think you guys are getting confused with this, okay? So these are the coin colors. Basically, this is type 1. I think people are getting confused with this. This is type 1. This is type 2. And this is the type 3, which got collected here. Fine? So which one is the heaviest weight right now? Tell me the color of these coins. What is this color? Is this yellow? I don't know. Yeah. You guys are seeing this to be yellow. This is blue, right? So blue coins are the heaviest weights, right? They are 10 grams. They have the highest value. Clear? Highest value. Fine. Okay. So this is 10 grams is the highest weight, right? So it has the most value, right? Very simple. The heaviest gold coin will have the highest value, right? Correct? If you get a 10-gram coin from me, you will be very rich. If I give you a 1-gram coin, you'll not be so rich, but you'll still be rich, right? So 10 grams. So this is the 10 grams coin. So whatever you have done right now, right? There was no label associated with it. There was no label. So you didn't know that this is a, say, 5 rupee coin, or this was not a 10 rupee coin, right? You did not have the label associated with it. But because of some feature of this particular data, you were able to categorize it in at least into these three groups, right? Or I can call them clusters. I was able to categorize them in three clusters. So whatever we have formed here, right, are called clusters. And you have learned your first unsupervised learning algorithm. It's called clustering. So Bhavesh is asking that, isn't it just like classification, but just that we don't know the labels? See, there is a very a minor difference between classification and clustering. So classification, right? You know what is the exact class it is being binned into, right? With clustering, you will see that, okay, there are three groups. The inference that you make is up to the user, right? For example, when I clustered them here, I have to make the inference, which is the uh, highest value coin, right? Or if I have to guess, right, like what will be the value of each coin, I will make that inference, right? So that inference that I'm doing based on these clusters is what the user has to do once they have received the clusters. So that's a minor difference. But in classification, you are right. You know what is the particular class that you are binning that particular data into. But in clustering, you will just see three clusters or four clusters or any number of clusters. What is happening in these clusters, or what you will have to identify, right? Machine will not tell you. It will show you that, okay, these have this common feature, this has this common feature based on domain knowledge. Okay, I'm introducing another term here. Based on domain knowledge. Domain knowledge means that, suppose this is medical data, right? So those three clusters might make sense to a doctor, but as a data scientist, a pure data scientist, you might not know, right? So domain knowledge is important in understanding a lot of machine learning algorithms and machine learning data. Based on domain knowledge, you might be able to identify certain features, characteristics according to, or like according to the clusters that you have received. Uh, but it will just basically give you, okay, these features look together, like they're like these features, these coins that you gave me, they look similar to me. Machine learning algorithm will tell you just this, the unsupervised learning machine learning algorithm. These coins look similar to me because their weights are similar. These also look similar because their weights are similar. These also look similar because their weights are similar. Okay. Now, because of this hint that I gave you, that the heaviest coin is a higher value, you will be able to determine the value order, right? But if this information was not there, you might not have known what is what is the value of each of this coin, right? So domain knowledge actually plays a lot of role in unsupervised learning. So whenever we used to do, clustering and used to make clusters, we used to go back to the doctors to ask, does this cluster mean something to you? Like, do you think these should be clustered together? Right? For example, there was one case where I had done a clustering on, I had used something called as UMAP. I'll show one example of UMAP in the next slides. It's also a unsupervised learning technique. So we had clustered and we saw like a particular data set I was working with. So these were disease patients. All the disease patients were there for a particular disease. Disease patients, right? And there was another cluster, a very big cluster for non-disease patients. So I was getting 3 clusters, non-diseased. So I was surprised why I have 2 clusters here, because these are all with the same disease. So they were same disease, right? So when I saw these 2 clusters, I went back to the doctors and they told me that this cluster has chronic condition. Chronic means they have it for a very long time. And this one is like, but this is like a temporary condition. So they had it for like a day or two and then it resolved. These guys have it for a very long time. So these kinds of insights you get after doing unsupervised learning. Obviously, you need to have the domain knowledge. So these only doctors told me that, oh, these guys seems to be have the condition from a very long time. They had temporarily this condition, but it got resolved. So that's why you have 2 different clusters. And model performance on these 2 clusters was very different. Okay. So we actually eliminated this data out and improved our model using this. So things like that happen a lot. But to come back, domain knowledge is important to analyze, right? Because the label is not there, right? So you need to understand what this data is. And once you have, like, for example, a medical data, you will need the medical expertise to understand. Hence, we used to work with doctors very closely and they used to give us insights, okay, what this data has. So this is our clustering algorithm. Uh, uh, so this is your first clustering algorithm. Based on some features, I have clustered them together. And these are 3 clusters that I have found, right? We are actually very good at clustering, okay? So I'll give you another example. Suppose that you are a baby, fine? You are like a 3-4 years old kid, or you have a 3-4 old sibling or a cousin. If you give them toys, like all of these toys, do you think the child can segregate these toys? Maybe let's say this is a 5 to 6 year old kid, right? Will this child be able to segregate these toys into, say, 3 groups, 4 groups, right? Yes, no, yes, right? These are the 4 groups, right? So here you have cars, you have teddy bears. The child might not know the name of these cars, right? Or name of these toys, but they can segregate this, right? And this is a duck, duck toy, right? Right? So the child did not know the labels of these toys, right? Still, it was able to cluster them. Why do you think the child is able to cluster them separately? Or why do you think, even not knowing that this is a car or this is teddy bear, these are balls, these are ducks, why do you think a child is able to cluster? Right. Based on some features, right? Based on some visual features. Visual features. There could be visual features, right? Or, touch also. For example, teddy bears are very soft, right? And this will be like moving. It has wheels, right? This also is like a wheel, but it's like the whole big ball, right? And even ducks are like yellow in color, right? If you squeeze them, you will get some sound, right? So there might be many features involved, right? Visual feature, touch, sound. Maybe this particular car, when it runs, it makes some noise, right? And uh, and this ball, right, the characteristic is like shape, right? So a lot of features uh, we are able to recognize, and we start developing this very early on, right? So if you can understand this, so a child can identify their mother's face very early on, right? This is basically, there is something called as pattern recognition. Pattern recognition. And we are apparently very good with it. I don't know. If I see a person, I can recognize them from, like, in a crowd. Or even if I just see their photo, right? So I can see them when they're in front of me. Right? So we are apparently very good at pattern recognition, and hence we got that pattern recognition skill into our machine learning algorithms that now you try to identify patterns for us, right? And it's being used at multiple places. Unsupervised learning is used at multiple places, right? For example, Google Photos uses for tagging your data, right? So for example, it will give you a suggestion. You might have seen that, right? Oh, can I tag this person to be this? How is it doing it? It knows only one. It identifies features. Okay, this person looks similar to this person. Can I tag it? I apparently had a very nice uh, incident sometime back. So I was looking at my old photos and it was asking me to tag one person. I was like, I had never seen that person. And that person was like a foreigner and I had never met that person. And I went to that photos, okay? So it so happened I had visited that restaurant twice and there was a photo behind me wherever I sat and of the same person. Okay. So from those two times, I think I was sitting on the same location. So that same photo was in the frame and there was that foreigner person on that frame. And the machine learning algorithm was detecting that this is the same person. So this happened like few years back. So I was very shocked, like how is it able to recognize this, that this is the same person and it's asking me to tag that person. So though it was just a photograph, right, on some wall, and I happened to visit the restaurant twice. So it's already being used by machine like big giants like Google, Facebook used to do it. I am not using Facebook anymore, so I don't know what is happening right now. But I've seen this in Google Photos, right? For example, if you search in your Google Photos, say food, right? All the food pictures will come, right? If you search for say nature, all the nature related images will come. How is it doing it? You have not talked every image, right? You have actually the Google is running a unsupervised learning algorithm back at your photos to understand the features of your photos, and hence it's able to cluster your photos into say nature, food, friends, water, ocean, beach, etc., etc. Right? So unsupervised learning, I am very interested in unsupervised learning domain. I find it very interesting because without knowing anything about the data, the machine is able to do this type of clustering, right? And this comes from how we cluster stuff. Or suppose there are 5 chits in front of you of different colors. You'll be able to do the clustering, right, based on the color. So I think the unsupervised learning, and there is a paradigm called self-supervised learning also, which we are not going to discuss, but people who are interested should go and read this as well. Very interesting domains. I think they are the future. Already they are they're already the present. A lot of people are using it. A lot of big companies are using it. Um, so very interesting domain. Okay. So fine. So now, so this baby was able to cluster these toys. How many clusters are there? 4, right? So the baby is very smart, right? So 4 clusters we have. So just based on some visual features, and that's what machine learning, unsupervised learning algorithms also do. Based on some feature that you might not be able to the feature that you might not be able to visualize, they will be able to detect it. And suppose you have thousands of features for data, right? They will be able to pick certain features and give you insights on that data. And so very useful algorithms. I personally love them a lot. Okay. Okay. So unsupervised learning continued. So I want to show you a very good algorithm that I've used, which is called UMAP. We'll see how UMAP works. But let's talk about this digit, right? So I was talking yesterday about that we feed image to computer, right? But I told you that computer only understands number. So that's the example for this. So this is the image. This is the written image. So this is a 28 cross 28 matrix, right? You basically send this matrix. So this is a matrix and you send this matrix. This is the actual values of this particular value of the image. I don't know. Can you see this pattern being formed here? Right? Can you see this? This is a similar pattern here. Obviously, this is not indented properly. 0 should be coming till here. But can you see how these images are, right? So wherever, so 255, sorry. So the 0 value means black, right? And 255 means white. These are pixel intensities or pixel values. Okay. So can you see that all of this black region has 0, 0, 0, 0, 0, 0, right? And these gray white values have like values greater than 0, right? You will see 255 somewhere. I think there might be 255 also. I don't know. I can only see 253 here, but 255 is completely white, right? So can you see this pattern emerging here? So this is how we feed data to the computer, right? So this is an image, but I'm feeding this data to the computer. So that's how you feed data to the computer. Clear? Right. Suppose that this is my data, right? This is 28 cross 28 matrix. So this is one example. This is one data point. So obviously I have to create one feature corresponding, like a feature row corresponding to it. So what I do is I decide that I will flatten it out. Flatten it out means that I had an image like this. I had like 28 rows, right? I paste every row together, right? So I get a 1 cross 28 cross 28 vector, right? So this is what that vector is. This is the flattened image vector for this image probably. Probably this is not correct, but the numbers are not correct, but you can flatten out your image, right? So this is a 1 cross 784 vector that you're seeing. I have just flattened out. Everybody understood how I have flattened out? So every row, I have just put every row together, right? So I've created one big vector, right? So this was 28 cross 28. What I've done is I made it 1 into 28 cross 28. So there are now 784 numbers here. Will you be able to visualize this vector? Like, will you be able to plot it and visualize it? So we can't see things beyond 3D, right? So we can't visualize this particular vector, right? But what we can do is we can do dimensionality reduction. What is a dimensionality reduction? What is the dimension of this particular vector? Okay, so this is a 784 dimensional vector. Can you plot this? Can you visualize it? No, right? So what will I do? I will basically try to reduce the dimensions of this. So the dimension of this vector is 784, right? I will try to bring it to 2D and still trying to keep as much information as there in this. So Rohan is asking, can we reduce the truncate? Can we truncate the zeros? Okay. So if you have multiple images, right? Some might have text here, right? So you might not be, if you have to remove zeros, you should remove from the same images, like same places. But some text, for example, if I write something here, right? Suppose I write X like this here, 2 like this here. So that information will be lost. So we can't do that. That's another thing that you should try if you want to try. Might work, but ideally we should not do that. We should take the whole image and then do the dimensional reduction. Okay. So I will take this 784 and reduce it to 2D. Okay. So I will flatten this image. I have flattened image. Then I have done something called dimensional reduction, which is again a unsupervised learning. Unsupervised learning. Supervised learning algorithm. Right? So we'll reduce it to 2D vectors. Okay. So this is the MNIST dataset, the complete MNIST dataset. And this image I have taken from UMAP. So this is an algorithm which is not in your syllabus, but a very good algorithm that I have used in unsupervised learning. So what it has done is it has taken every image from this MNIST dataset. MNIST dataset is those 10-digit handwritten digit dataset that I was talking about yesterday. How many clusters do you see here? How many digits are there in this data set? How many classes are there in this data set? Suppose the labels were not available, right? So what you could have done is, suppose MNIST data set was not coming with the label, true label of the digit. What you could have done is, you would have done dimensional reduction. Here, each class is basically a digit. Okay, I don't know what digit is that. So what I'll do is I'll go to this cluster. I will check the digits. Okay, seeing some images, I will be able to recognize, oh, this is, for example, 3, right? So whatever images or whatever points that I have in this cluster, right, I will tag them as 3, right? Again, I will go to this cluster, very clean cluster. I will look at the images of this particular data set. Okay. And then I will look at some images and I will recognize, oh, this is 1, right? So this is 1. And similarly, I can go to every cluster and tag it, right? So all I have to do is check few images from this cluster and I will know that what cluster, what point is being pointed here or what image is being pointed here. I can just write an algorithm. It will tag the whole data in like few minutes, right? So this is another application of unsupervised learning, which I was talking about, that you can tag data using unsupervised learning. So this this might not be exactly correct, right? For example, you can see data here. This basically belongs to this particular cluster, right? So you might have some errors, but like yesterday I talked about, we do have errors in labeling, but that's okay. But can you see at least 90% of the data will be well tagged, right? And you can always do multiple iterations of this and improve your data or labeling, right? But you will get an initial label set, initial label you will get to, to train some classification algorithms. Sure. Does that make sense? This is the same thing that happens with images, okay? So your images, they are basically, the dimensional reduction happens, and then they see which cluster do they lie in. For example, if a image got dimensional, you have a very nice image on a beach, for example, and they will reduce the dimensionality of that image. They'll bring it to like a 2D or a 3D point, and then they will see which cluster it is closest to, right? And whatever cluster they have, they must have already labeled that cluster. And then that label, they will suggest, this is a beach image, right? And hence they don't automatically always tag. And sometimes they ask you, they're doubtful. Is this a beach image? And you will say yes. And then they'll tag it. I'm discussing what is happening. I have not given the details of this. This is something that we will see in the course, right? This is whole 3 lecture ka topic, dimensional reduction, right? I'm just telling you this happens, that it's reducing it to using some technique. Just understand the concept. The details we'll discuss later. This is just an introductory lecture. Okay, so somehow this dimensional reduction is happening. We will see PCA. We will see this particular algorithm called PCA in detail, but this is just a gist of it. The gist is clear. Hence, it's unlabeled. I'm saying if MNIST did not have a labeled data set, this is how you would have obtained initial labeling for MNIST.